Well, 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 I see you're back. Or are you a new viewer? If so, let us know in the comments. And thanks for tuning in to the Smash News Network, least busted name in news. We're looking at the past 24 hours on the closest star. That's ionized iron and helium from the Solar Dynamics Observatory. You might see some activity happening up there in the northeastern limb. A filament collapse. A CME happened, and lots more. We'll tell you all about it today on the Daily Space Weather. So here's a little closer view of a series of features happening. A filamentary collapse. There is also a filamentary reorientation and CME coming out of the North Polar region. Also a CME coming out of the northeast. So lots of interesting stuff going on. Also a new sunspot rose right there in the lower left of your screen. That'll be known as sunspot 3380. Great view of that filament collapse, as well as a secondary Hyder flare event. You see that brightening? That is plasma splashing back down toward the chromosphere. Again, there's that new sunspot. That'll be 3380. This group down here, unfortunately, was never named. It should have been named. Somebody dropped the ball on that one. It was there for over 24 hours. We documented it on the channel. Here's the western limb, some large filaments setting there, as well as some significant sunspots, and there's definitely some instability likely happening up here in the northwestern limb. That, along with the southeastern limb, are the two most likely places, in my opinion, for a large solar flare. We'll talk about flares. We'll even do a cosmic ray report today. And before we do any of that, let's look a little bit closer at this filament collapse and CME producing region from yesterday. That would have been July 22nd. And whoops, there it goes. That is some pretty sweet imagery indeed. So let's take a look at sunspots here briefly. Here is yesterday plus today from SDO intensitygram, SDO continuum as it is. And not a lot of sunspot evolution happening there. Most of those groups stable over the past 24 hours. It looks like one new group formed and then evaporated right here. Besides that, just that rising beta gamma class sunspot group down there in the southeast. Here's the colorized magnetogram for that same period. That is July 22nd. And July 23rd to date. And we'll go over what's going on planet Earth. First, take a moment to visit our links. If you haven't checked them out, there's a link in the description to our Redbubble shop. So scope that out. It's right below the video. And today's featured product is Do the Math. Do the math. We've shown the work. 8 == capital D, and we hope you don't suck at math. If you do, maybe science isn't the realm for you. But in any case, it features a great ultra-high resolution image of Sagittarius A star there. That is the core of the Milky Way galaxy, and we offer this product in various different things. Socks, book bags, how about a shower curtain? Duvet cover? Anyway, we invite you to do the math. Did you know that I was a computer science / math major when I first graduated high school? Yeah. It's part of the reason why I'm so offended by junkware on the internet. Yeah, barely functional software on the internet known as junkware, which, by the way, has been upgraded since 2020 to deathware. So do the math. You're invited to visit the links below this video. Our featured product on Amazon is Anthony's Organic Cocoa Powder 2-pound bag. You'll pay like 1/80th of what you would pay in a grocery store for non-organic cocoa powder by picking up our cocoa powder, known to improve nitric oxide levels, which effectively increases your blood oxygen. A lot of athletes take nitric oxide when they could just be consuming cocoa powder. I had some in my coffee. My first little small cup of coffee this morning had both cocoa powder and cayenne pepper. You can find bulk cayenne pepper on our Amazon shop as well, so check that out. Links below the video to that. Also to our Hemp Lucid shop. Stress less, CBD more. Improve your health, perhaps your sleep, perhaps reduce stress. perhaps reduce inflammation or treat an injury. Who knows? Sometimes we athletes become basically just a walking collection of injuries. So check out the CBD products. You can find a link on the homepage at smashomash.com, as well as below this video in the description to our Hemp Lucid shop. Let's take a look at what's going on Earth. Starting out with volcanic eruptions, and it looks like here we've got some. This is what you call FRI, F-R-I, Future Rocks of Iceland. Just boiling up in a cauldron there. It's pretty sweet. It looks like the lava flow has returned to its original stage. However, the lava flow on one side is reaching up toward the cinder cone there. So that's like looking like it could build up and overflow and start to turn into a shield volcano. So anyway, that's what's going on at Iceland at the moment. That's a real-time webcam for you. And let's see what else is erupting here. Abiko producing a 10,000-foot ash plume. 5,000-foot ash plume from Subanose Jima. It's a flight level 050. Unknown ash plume over Mayan. Karengatang producing an 8,000-foot ash plume as it explodes. It's a flight level 080 over Siau Island, part of Indonesia. Semeru also producing a 14,000-foot ash plume as it explodes. Flight level 140. Shishildin also erupting 15,000-foot ash plume there over the Aleutian Islands. That's a big uptick at Shishildin. Significant eruption there. Flight level 150. Next on the list is Popocatépetl. Exploding. Flight level 250. 25,000-foot ash plume over central Mexico. That is on my bucket list to see. Popocatépetl. Nevado del Ruiz. Volcanic ash not observed. Don't assume it's not erupting in Colombia. Sangay in Ecuador is erupting, producing a flight level 190. It's a 19,000-foot plume of volcanic ash. Please don't pole vault the caldera. Sabancaya producing continuous emissions there. No indication of an ash plume size. And Ubinas in Peru also erupting in an explosive fashion. Flight level 220, 22,000-foot ash plume over Peru from Ubinas. As far as seismicity goes, it's been very quiet over the past 24 hours. In fact, it's been so quiet over the past 24 hours that I can tell you right now how many earthquakes have happened of a 5+ magnitude. And the answer is 0. 0 5+ magnitude quakes, folks. What happened? I vanished. There we go. So I'm just going to scroll up the list here. Let us know in the comments if you think we've missed something. 0 5 magnitude quakes for the past 24 hours. It's a bit of an earthquake drought over the past 2 days here, so it could be the calm before the storm. We have had some forecasts in previous videos looking at some space weather data, the possibility that some quakes may occur. See our previous space weather video content for details. We do this daily, so you don't have to. And there were a series of features that we didn't see covered, so we decided to occupy the niche of space weather and Earth weather together. That said, let's get back to space, and let's take a great close-up here at this new rising sunspot region. So that is another 24-hour video there from SDO 211 plus 171 angstroms. Here's the full disk zoom. And here we'll subtract 211 angstroms. That's SDO 171. It's a 24-hour video. And let's take a look at some more space weather stats here. The 10.7 centimeter radio flux, now at 174 solar flux units. And for our regular viewers, they're well aware that the radio flux is a proportional data set to sunspot number. There it is. The red line is a sunspot number. The black line is a radio flux. And 174 is right near a support level. So you can see multiple peaks right around here in the mid-170s. And there's a bunch of activity on the far side of the sun here at the moment. We're expecting this to break out of 170s pretty soon. In fact, that new sunspot might break it out above 180 in the coming 24 hours. Space Weather Enthusiast dashboard here from NOAA. That's NOAA's forecast for space weather. Not forecasting any geomagnetic storms, although a period of brief geomagnetic unrest is on NOAA's forecast there. That would be late in the day tomorrow, Monday, July 24th. Now let's talk about how we are not at solar maximum yet. There are many reasons why we are not at solar maximum, and one of them is cosmic ray flux. Now there are many other reasons why the previous solar minimum, the one between solar cycle 23 and solar cycle 24, was a very minimal minimum. There were a very low number of sunspots. The thermosphere was the coldest ever measured. And cosmic ray flux was at the highest level it ever was. Now, for those of you not familiar with cosmic ray flux is a direct indicator of solar activity as well. Or you could say an indirect indicator, I guess. It is inversely proportional to sunspot number. So, if anybody's been telling you that cosmic ray flux is at the highest level it's ever been, I would put your attention on this graph right down here. This is Oulu's neutron monitor going all the way back to 1964. And as you can see, this is where cosmic ray flux is now. And this is where cosmic ray flux was around 2010. That is the highest cosmic ray flux ever measured. And now it has been higher in the past, according to the geologic record, as we do see isotopes that indicate there were higher cosmic ray flux levels, but at least in terms of directly measuring the cosmic rays. And if you're not familiar with what cosmic rays are high energy, high speed particles from space. They typically come from outside the solar system, and they are traveling at a significant percentage of light speed. So most of them are just hydrogen nuclei. There is only one known cosmic ray point source. And there are heavier elements as well in terms of cosmic rays. Think of them as little bullets flying through space at incredibly high speeds, which cause particle showers when they show up at Earth. Anyway, so they are relevant not just in terms of their inversely proportional relationship to sunspot activity, but they're also possibly involved with things like cloud formation. Anyway, that's Oulu's neutron monitor, and over the past 30 days we only see a mild downtick. And we're expecting this to get quite a bit lower here because we're expecting it to get quite a bit lower than it was at the peak of solar cycle 24, since this is clearly a much, much stronger solar cycle than solar cycle 24 was. So this is an indication that you can expect solar activity to continue to increase for the next 8 to 9 months. Here's DOMB Antarctica showing only a modest downtick as well. Here's DOMC Antarctica, also a modest downtick there for the past 30 days. Let's go way down south to the land of Mexico City. Only a modest downtick in cosmic ray flux there. We're expecting a much more extreme downtick in the coming, again, 8 or 9 months. Let's go a little farther north to Athens, Greece. There's Athens, Greece. And Athens, Greece is actually showing an uptick. So there's another indication that we're nowhere near solar maximum yet. There's quite a way to go. And let's go back up north to Apatity and Barentsburg. So there is Apatity, only a modest downtick there over the past 30 days. And here is Barentsburg, also only a modest downtick. So again, expect continued lower cosmic ray flux for the coming nearly year. And that's just one of the many indications that we are nowhere near solar maximum. Anyway, let's take a look at what's going on in the Earth environment here. So some more space weather data for you. Here's Earth's magnetic moment from space. This is part of the reason why we say Earth is shaped like a croissant, not an oblate spheroid, because Earth's magnetic moment from space does have some features of the French breakfast pastry. So there are the past 4 hours. It's pretty chill at the moment. Just a nominal solar wind, and looks like some variations happening there. We'll cover those in a minute. That's the past 4 hours of Earth's magnetic moment from space. Here are the past 4 hours of Earth's magnetic moment from the ground. And if you do happen to have any auroral imagery or any other imagery you'd like us to share on the channel, hit us up on Instagram or on Discord. You can find a link on the homepage to that. Or you can hit us up on Twitter. The best way is to tag us in a tweet, not to send a message because there's so much spam. So the KP index currently at 1.66. There it is. 1.6666666666 rounded to 1.67. 1.6, if you're a math nerd, is how you would notate that. Or you could say 1 2/3. KP 1 2/3. So that's a KP index, a general average of global geomagnetism. So here's a real-time solar wind, and here are these little variations we just talked about. So some little density and speed variations happening there. Also a little shift in the magnetic field. Current conditions are about 3 protons per cubic centimeter for the solar wind. Oh, make it 4. 4 protons per cubic centimeter for the solar wind density. Solar wind speed here just over 400 kilometers a second at 424. GOES magnetometers here are pretty chill. Seeing kind of low highs here. Low highs and sort of normal lows on the GOES magnetometers for the past 3 days. Past 24 hours had low highs for sure. That's noon local time for the satellites there. Not even making it over 100 nanotesla. Next, we'll look at something super important. It's the heliospheric current sheet, and there's some activity going on once again here that you should be aware of. We've got North Pole magnetism showing up at the North Heliographic Pole once again. Another indication that we are not at solar maximum. So, I mean, facts are facts, and they don't care about your cult. If you're in a cult, maybe I don't know, exit the cult. Stop believing nonsense about solar activity. And anyway, that's the top view ecliptic plane field plot. It depicts the magnetic polarity of solar plasma. And yeah, at the moment, Earth is in a North Pole current sheet, depicted here in green. South Pole current sheet coming, possibly as early as tomorrow. I would suspect not until Tuesday. But that's our top view ecliptic plane field plot. Next, we'll show the line of sight field plot. Here, the sun's B field is depicted in blue, north and south polar fields in green and red respectively, and the grayscale is the gong magnetogram. Lots of organized magnetism on the Earth-facing portion of the solar disk. And here's our line of sight coronal hole plot. We've got mostly south pole coronal holes except in the southeastern limb, moving toward the center of the solar disk, actually. There's the latest image. And let's take a look at coronal holes here from the STO 211 angstroms wavelength. So there you go. There are coronal holes. These are, as forecast, getting more well-defined as they move closer to the Earth-facing portion of the solar disk. The rest of these are south pole-oriented coronal holes. And let's move to sunspots. So first we'll take a look at the Integrated Space Weather Analysis Center's ASAP flare monitor. And it's still showing very high probability of a large flare. Okay, it's showing a large flare likeliest from, most likely from down here at 3373. So here's my forecast. Possibility of an X-class flare are highest in these areas. So once again, it's the northwest and the southeastern limb most likely to produce a large solar flare. Sunspots like to make a grand entrance and a grand exit, producing large flares most commonly at the limbs, an effect which is actually even more pronounced at solar minimum. Anyway, Here are the past 24 hours from SDO in the SDO continuum wavelength. It's actually a series of wavelengths, hence the term continuum. So again, not a lot of evolution happening here. These groups down here, those are still sunspots, so those might be known as 3380. There's another small group here that might be 3381. So we may have as many as 3 new named sunspot groups today. These ones down here in the southwest, those are quite modest. This one rising in the southeast is quite significant. So let's also throw together 304 angstroms and the SDO magnetogram. Great at showing the way the ionized helium there orients to the magnetic field lines. And let's move on to energetic particles and solar flare. So as far as solar energetic particle events, we ain't got none. It's the ghost proton flux there, flatlined. X-ray flux here, still hanging out in the C-class range. It's about a C1.4 X-ray background output. No major flares. This one was only a C9.96 or something like that. Not quite an M-class flare, about as close as you could possibly get. Let's take a look at our flare wavelengths. There is 94 plus 131 angstroms from SDO. And that most recent large C-class, nearly M-class flare came from this group right down here. Here's a close-up view of this region that was associated with some CME activity and some plasma reorientation events. The northeastern quadrant. And there is the full disk equatorial zoom. And just to reiterate, the most likely places would be your upper right, that's the northwestern limb, and the lower left, which is the southeastern limb. Moving right along, we've got some awesome imagery for you today of coronal mass ejections. We decided to put together some difference imagery. Now, keep in mind, folks, this channel has barely begun creating space weather content. I mean, we're trying to create a sustainable operation in doing so. So that's another reason why we encourage you to support the channel. And of course, we encourage you to look up. If I were to look up and see a dark sky right now, this is what I would see over Lehigh Valley, Pennsylvania. Of course, it is light out. That is our sky chart from skyandtelescope.org. And just a quick reminder, if you're viewing the dusk sky, you get a great view of possibly Mercury as well as Venus and Mars. Very close together there, forming a nice triangle around the ecliptic. Also Regulus right there in between Mars and Mercury. So a great time to view the dusk sky if you've got clear skies. If you've got a low horizon and low light pollution, you might even be able to see Mercury down there just after sunset. Here's your solar system forecast, because here at the Smash News Network, Least Busted Name in News, we like to provide value-added services. So this is your solar system forecast. Here's where things are today. We'll move this ahead 1 week. Here's where things will be on July 30th. As we approach the August full moon there, we've got a gibbous waxing at that point. And let's move to CMEs. Yeah, CMEs. So there's a great one coming out of the west. That is not earthly directed. And here comes one out of the north and out of the northeast. I don't think that is earthly directed. However, we'll have to do some further analysis of that. So that is 103 frames from yesterday. Here are an additional 42 frames from today. And that CME might be earthly directed. So right there. Now wait, right? All right, maybe not. All right, anyway, let's take a look at LASCO C3 as well here. Here's LASCO C3 and C2. I do not suspect any of those have an earthly directed component. Let's look at stereo A as well. That should give us some additional information. Feel free to pause the video on this frame if you're not familiar with the positions of BEPI and the Solar Orbiter and the Parker Solar Probe, stereo A and B, etc. So here we've got stereo A on the left, and once again, LASCO C3 on the SOHO spacecraft on the right. And let's bring up this morning's CME here. All right, so there's one. It's coming mostly out of the north and the west. And we look at stereo A. I don't anticipate that to be earthly directed. However, let's take a look at our custom coronagraphs, as they are quite spectacular indeed. There is the past 24 hours. And we've got a comet captured once again, right in here. And what we did here is we've utilized the base difference imagery. It's just the pixels subtracted from the previous pixels for a certain period of time. And we just left those in their base settings here because it does obviously show quite a bit more contrast there. And I don't see anything indicating that those coronal mass ejections are earthly directed. So I suspect there are no earthly directed components from those. Here's an even closer zoom. It's SOHO LASCO C2 and SDO 193 angstroms. And we'll also talk filaments. Before we do that, let's show one more video here. This is the past 24 hours in SDO 171 plus 304 angstroms, two of our favorite wavelengths. That is great at showing the lower corona, also plasma filaments. And you'll note quite a lot of motion, especially in the northeast. By the way, that filament was named. If you want to name filaments, you'll have to join us over on Twitter. So speaking of filaments, here's the current situation from the El Teide, Spain ground-based hydrogen alpha telescope. And this filament was named the Cardi B filament. Maybe the next one will be called the Nicki Minaj. But that one has mostly ejected or collapsed. So there it is, and whoops, now it's mostly gone. There's still a little remnant of it there, but most of it is no longer at least where it was. So that's the El Teide, Spain ground-based hydrogen alpha telescope. All those dark features are plasma filaments, which could relate to earthly space weather activity should they eject and strike Earth's magnetosphere. Last but not least, here are the past couple of hours. This is last before our bonus feature segment, by the way. There are the past couple of hours from the GOES 18 SUVI, looking at ionized helium. Again, we've got a high likelihood of large flares up here, and a slightly less high likelihood of large flares down there. Check out the plasma instabilities happening up here. And this brings us to our bonus feature segment. So first thing we're showing here is the Satellites Community Dashboard. There are the current charging hazards, and they are non-existent. No charging hazards currently. It's smooth sailing for satellites. Next, the GOES electron flux, and we're back down to low levels here for the GOES electron flux. That's the past 3 days. Those are the radiographic measurements from the geosynchronous orbits of the GOES 16 and the GOES 18. They orbit at a very high altitude, and they measure the electron flux at the F layer of the ionosphere. So here is the 1-year chart to put it in context. Again, at low levels of electron flux here at the moment. That's from solon.info if you want to follow it yourself. Here is the forecast model by NOAA. And NOAA is expecting similar levels today, followed by a little uptick. I have no argument there. Feel free to pause the video on this frame if you're not familiar with distances to these things in miles and the penetration of electromagnetic radiation and the atmospheric temperature inversion layers and so forth. Here is the layer where that's measured, the F layer of the ionosphere. That's one slice, the portion at about 300 kilometers of altitude. And I do believe we have this no major anomalies happening here. I stand corrected. Doesn't look like anything significant going on. The ionosphere is looking quite normally at the moment. And if that looks like Greek to you, that's the raw vibrational frequency. We'll also show the anomaly in megahertz from a 30-day median. And the majority of the anomalies are around the South Atlantic anomaly, which is over the South American continent, as you may have come to expect, especially if you're a regular viewer of the channel. Again, if you're not a regular viewer of the channel, why not press the subscribe button? Did you know that our thumbnails contain more information than entire channel's repertoire of content? Yeah. Just our thumbnails have more information than entire channels. There's a latest image. That's 1130 Universal Time Ionogram and 1130 Universal Time Anomalygram. We also show the total electron content daily on the channel. It is the free electrons from about 12,500 miles of altitude down to your GPS handset. Feel free to pause the video in this frame if you're not familiar with things like the distance to your GPS satellite, the altitude of the SDO, or perhaps the altitude of the Van Allen belts. Here is a total electron content forecast, and we're seeing significant anomalies once again here. So big nighttime GPS errors are likely. Also huge anomalies there south of Australia, in the Southern Ocean, south of the Indian Ocean, south of Africa, around Antarctica, and the Southern Atlantic. So that's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model, depicting the most likely places to see GPS errors via free electrons. Here's a total electron content anomaly from the 10-day average over North America. We are seeing some low electron content anomalies there off the coast of Baja California, but no significant high electron content anomalies here. So nothing too major going on there. And let's close out the space weather section of the video with the latest intensitygram and the latest SDO magnetogram. There's one, and there is the other. So we'll briefly take a look at this new sunspot. It is looks like it may be backward polarity, folks. I only see one umbra, and it is North Pole. So that looks like a backward polarity sunspot, folks. Is it a solar cycle 26 sunspot? It has a leading North Pole umbra. So that's interesting, to say the least. That is a leading North Pole umbra. I'm almost 100% sure of it. Here's this group, which does indeed have a high propensity to produce large solar flares, although it just is barely beta gamma delta class. Just barely beta gamma delta class. There is some magnetic shear there, though. As far as the rest of those groups there, they're pretty unremarkable. Here's the rock back. Which brings us to meteorology. So we like to combine our meteorology videos with our space weather. We used to make them separate, and you know what? It got us less views on YouTube. So if it don't make dollars, it don't make sense. We were even forecasting CMEs. That didn't increase our views either. So we stopped doing it, period. I mean, you incentivize people to do stuff or disincentivize people to do stuff, and they'll do it. Once again, if you want to name filaments, follow the hashtag NameThatFilament over on Twitter. We even just created a tweet about it. Right there is the link to the hashtag. Yeah, you can follow a hashtag, just like you can follow an account on Twitter. And no, free speech has not been fixed by Elon Musk. What a joke. What a poser. You can also find us on Instagram if you like things like fitness, lifestyle, and diet posts, your daily motivation to do stuff like ride your bike, and fitness tips that you won't get anyplace else. Follow us over on Instagram. All kinds of links below this video to the Instagram site. You can also find links on the homepage at smashomash.com, the official homepage of the Smash Team. Links to the Smash Team there. We'll talk about that before the video ends. Smashomash.com, the homepage of this channel. And welcome to the Neo Renaissance. Congratulations on realizing the Smash News Network, least busted name in news, exists. Now we're going wave chasing. I'm interested in where the largest waves in the world are. Here are the stormiest seas. They're in the Southern Ocean. We've got some 36-foot waves down there south of Australia. And those are by far the stormiest seas. People might be talking about these lows, this one by the Philippines, or maybe this one over here in the Atlantic. That's only got like 25-foot waves. Oh, 29-footers. All right, that's impressive. It looks like it's intensifying here, folks. It has been moving into warmer water exactly as we forecasted. So that's just a matter of understanding the way physics works. And let's move to our regularly scheduled meteorology segment. So it's calm seas over most of the planet here. Not a lot of locations with big waves. But some high winds in some locations indeed. So those are the surface winds of the eastern world. Here are the jet streams. Still blowing backwards over the Indian Ocean, the northern part of it at least. Here are the jet streams of the west. We've got a great N-shaped jet stream over the U.S. And here are the surface winds. Surface winds of the central world depicted here. Congratulations to Jonas Vingegaard, as he is almost 100% guaranteed to win the Tour de France today. Did a fine job, put down one of the best time trials in the history of the sport. Here are the jet streams of the central world, and significant jet stream there blowing backwards over northern Africa, the northern Indian Ocean, and then making a huge bend, both at the equator and north of the equator here. That is what's going on. Next, we're going to show you a forecast here. So we'll show a couple different models. So here is the forecast model for the Euro model for this. I guess it's a hurricane now, but the winds only look like they're like 60 miles an hour, but I'll just assume it is a hurricane. And let's show the storm track here. We'll show the 3-day storm track here for the Euro model. So it looks like in 3 days it's going to be broken up on the Euro model. The GFS model also shows it breaking up. And the Icon model shows it a little more concentrated, but also broken up. So it doesn't look like it's going to amount to much there. It's going to be torn to pieces, it looks like, according to Windy.com's forecasts. Next, we'll show you the clouds and fog scenario over the U.S. and South America. Here it is. This is shortwave radiation. Shortwave infrared, depicting clouds and fog when it is too dark to use the visible satellite. So there you go. There's clouds and fog. Here is your smoke forecast. And it looks like there is some smoke going to spread down toward Minneapolis and the Great Lakes region, also around the Oregon-California border. There'll be some smoke emanating from there. Also in southern Washington, some fires raging there. That's your smoke forecast from firesmoke.ca. And let's head to weather.gov next. There is the weather.gov scenario. We'll briefly scroll down and show you the key. Mostly excessive heat warnings there. So check it out, a blowing dust advisory. I've never seen that one before. Blowing dust advisory. Fun fact, most of the dust in your house is human skin cells, followed by insect parts and then pollen, I think. Yeah, like 80% of your dust is you're recycling your skin cells by inhaling them. Isn't that fun? Here comes some forecasts. This is the GFS 72-hour forecast for temperature anomaly in degrees Celsius. GFS 72-hour temperature anomaly forecast in degrees Celsius. Here is the GFS 72-hour pressure and precipitation forecast. The most extreme weather will fall on the Gulf Coast, as has been common throughout this year. Most of it will be in the Gulf as opposed to on land, though. The Carolinas and Florida expected to get a little hit there, also Ohio and Indiana. Here is your jet stream forecast at 250 millibar winds, based on the same model, the GFS 72-hour model. We're going to have a quite incoherent jet stream here as an anticyclone moves from Arizona toward Texas. You can see this significant clockwise rotation happening here. That is a high-pressure zone as clear skies move over the Texas stovepipe in the coming 3 days. Next, we've got your lightning mapper. This is what's going on lightning in the past about 10 hours. And here is the past hour of lightning strikes. Just give that a minute to connect there. It's well worth it. Lightningmaps.org. And we do have some Gulf Coast lightning here. South of Panama City, all around Panama City. Hey, Panama City, there is thunder rolling in. Next time you hear thunder, check out lightningmaps.org. Impress your friends and foes by forecasting thunderclaps. By the way, if you enjoy the content, press like, subscribe, share, etc. As I don't think YouTube's recommending the content, and our views are all over the place and they make no sense. So you would think that space weather is an emerging and important feature of the internet these days. If you're new to the channel, do yourself a favor and press subscribe. Again, our thumbnails have more legitimate information in them than some entire channels on YouTube, including channels that have like 10 times and 100 times as many subscribers as we have. If you enjoy the content and you want to support it, increase the probability that these videos will continue to exist, remain publicly visible and free for all to view, become a member of the Smash Team, especially at the silver or gold level. The best value is the gold annual paid-up subscription, as it entitles you to complimentary merch. Did you know that with a gold, even a monthly gold membership, you can get an @smashomash.com email address? Most basic names are still not taken. If you want to be Jim at smashomash.com, just join at the gold level. You've only got to join for 1 month. You'll be able to read about our theory as to the mechanism underlying the solar sunspot cycles. Yeah, the theory is a pile of crap. Yeah, my crap theory, CRAPF. And I'm not going to tell you what it stands for on this video. That's going to cost you $9.99. Smashomash.com/SmashTeam. And we'll close out with the U.S. Doppler radar. Clouds and fog over the U.S., lower 48. And the water vapor map. So cool air from Canada pushing down here again, once again into Pennsylvania, as an anticyclone moves toward the Texas stovepipe. So here is the recap. U.S. Doppler radar depicting vertical motion in the air column. Looks like Florida's going to get hit by some of that severe weather in the Gulf. It's moving to the east-northeast at the moment. Here is clouds and fog. Rapid cloud nucleation happening there as hot water occupies the Gulf of Mexico. And we hope you're not in hot water by not understanding how to forecast your own weather. If you watch our channel, you're probably well aware of how to do it. Anyway, thanks for tuning in to the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Back to the bunker. Whoa!